Alright, I've got an example here for two different samples, and we need to determine the test of hypothesis, the null being that the two means are equal, and the alternative is that the two means do not equal. So clearly we have two means, so we've got a few different possible options. Now, looking at these values, I have n1 of 17 and n2 of 12. There's no indication that these are of dependent nature, so we're going to assume that they're independent. Now, trying to determine what test to run for the hypothesis test, there's three different possibilities when we're dealing with means. Large sample from mu1 minus mu2, small sample, and paired difference. Now, paired difference is only indicative if we have dependent data. We don't have any indication of that, so we have to assume that they're independent. And the threshold for n1 and n2 being large enough is 30, so we're not going to use a large sample, so we have 17 and 12, so we're going to use a small sample. So the calculator function we're going to use is the 2-samp t-test, or 2-sample t-test is what it means. And the calculator function would be stat, then tests, and then the 2-samp t-test. Alright, and here I have the t-distribution set up here so we can find our rejection region. Let's do that first. We have alpha is 0.05, so we're going to cut that in half and use 0.025. And we're looking for n1 plus n2 minus 2 degrees of freedom. And the degrees of freedom, let's put that in. So 27 degrees of freedom is what we're going to use. 17 and 12 is 29, minus 2 is 27. So our critical value, or values, we go down the 0.025 column because we're doing a two-tailed test. We're going to cut alpha in half. And we go down to 27. So 27 and 0.025 meet up at 2.052. So that's going to be my critical value. Let's draw a couple lines. So right over 2 and right under -2, something along these lines. So these will be our rejection areas here. So that's a rejection region, and this is a rejection region. So if our test statistic falls into either region, we will reject. Alright, so according to this, we're running the 2-samp t-test. So stat tests 2-samp t-test is number 4. We have statistics. Our x1 bar is going to be 5.4, so we're going to enter 5.4. Standard deviation for sample 1 is 3.4, and we're looking at 17. And for the second distribution, we have 7.9, 4.8, and then 12. And we're testing doesn't equal, so that's good. We are going to pool, and this should be our test statistic. So our test statistic is negative 1.65, basically. And now we're going to put this on here. It's going to fall right about here. So because it doesn't fall into either rejection region, we fail to reject. Okay. Now, we can also note that our p-value here is 0.11. That value is greater than 0.05. Therefore, we will also fail to reject. So there's our conclusion using the p-value method. And the last thing we want to do is try to do a confidence interval for the difference. And those, we have a small sample. There's our formula. We can put everything into the formula, or we can use the 2sampt int. Int meaning interval. That's what we use for that. Move this over a little bit. Nope, sorry. Okay. So stat tests and excuse me, one up. So 0 on the 84 is the 2sampt int. Now it should have all the same information down, so we'll just check that. 5.4, 3.4, 17, 7.9, 4.8, 12. So it has everything set up. It looks like the only thing we need to change here is this is going to be 0.95, so we can run the same sort of testing procedure with this confidence interval that we did with the test. Alright, so between negative 5.62 and positive 0.61 or 62. So this is our confidence interval. We're 95% confident that the true difference in means will be between negative 5.61 and positive 0.62. Well, the number 0 is within this confidence interval, and as long as the number 0 is within the confidence interval, basically we're looking at mu1 minus mu2 being equal to 0, we have to fail to reject. Now if both of these numbers were specifically negative or they're both specifically positive, then we would have to reject.